Alright, looking at answers to the Unit 7 test review. We're going to start off with number 1. I'm going to work it over here on the side. Number 1, we need u to be x squared plus 2x. My derivative is 2x plus 2. And don't forget the dx. I have x plus 1 in my problem, so if I divide by 2, I get the x plus 1 that I'm looking for. So that means I need to add a 1/2. Out front, I'm going to have 1 over u du, and then I need to change my limits. So we're looking at 1 and 2. If I plug 1 in, that's 1 plus 2, which gives me 3. I plug 2 in, so that's 4, and that's 4, which gives me 8. Integrate. And plug in. Okay, and we know that if we have a natural log minus a natural log, we can combine those into one natural log by dividing. So that would be 8/3. So that's the answer I'm looking for on number 1. Number 2, my u on number 2 is 7t squared. So that means du is 14t dt. So I have the t, it's got a 2, I've got a 14. I'm going to divide by the 14. And then we're going to adjust. So I'm going to pull the 2 out that's over there. I've got the 14 here. And then we have 3 to the u du. So this turns into 1/7. If I integrate that, that's going to be 1 over the natural log of the base, which is 3, times itself, plus c. And then all I have to do is plug my u back in. So 1 over 7 natural log of 3 times 3 to the 7t squared plus c. There's my answer to number 2. Alright, number 3, using substitution u equals 2x plus 1 and that integral, which one of those does it match up with? So u is 2x plus 1, 2 dx. It does not have a 2 in the problem, so that means I need the 1/2 du dx. So I have the 1/2 there. We have the square root of u du, and then I need to change my limits. So 0 and 2. If I plug in 0, I get 1. I plug in 2, I get 5. So we're looking for that match from 1 to 5. I'm hoping it is E, since it's not pictured. Alright, no. Oh, C is the answer. I missed it. C is the answer, which is what we have. Alright, number 4. Number 4, the limit of the Riemann sum has been provided to you. Write the corresponding definite integral. So we're going to have our integral. Notice there's nothing in the parentheses being added or subtracted to 4I over n. So that means my a is 0. Then I look here and I look here. I notice that b minus a is 4. So I need to go 0 plus 4, which means that's 4. Take this out, put the x inside of it. So that's 7x cubed plus 2. And then a lot of us on the quiz forgot to put the dx on there. Don't forget to put the dx on there. That's 5. U on 5 is going to be x cubed. Du is 3x squared dx. There's a 5 in the problem, not a 3. So I need to move the 3. Which gives me that. I pull the 5 out, put the 3 underneath it, and then we have tangent of u du. Okay, remember you want to think about what's on the bottom of tangent. Tangent is sine over cosine, so that means we want the natural log of cosine, and since it starts with a c, I've got to be negative, and then we're multiplying by the 5/3, and then plus c. So we're looking at negative 5/3 natural log cosine of x cubed plus c as my answer on 5. Alright, 6, my u is going to be 4x. du is 4 dx. There's no 4 in the problem, so it's going to be 1/4. It's got a 5, so I take the 5 out with the 1/4, and we have cotangent of u du. Cotangent is cosine over sine, so sine is on the bottom. That's what goes inside your natural log. Okay, sine starts with an s, so that means it's going to be positive. Don't forget the plus c, and then make sure we plug our u back in. There's that. Seven. A particle with a velocity at any time t given by v of t equals e to the t moves in a straight line. How far does the particle move from 0 to 2? So we just need to integrate velocity. So we integrate velocity, we're going from 0 to 2. If I integrate e to the t, I get e to the t. We're going from 0 to 2. So e to the 2 minus e to the 0. And we know anything to the 0 power is 1. So that makes our answer A. Alright, 8. Our u needs to be 3x minus 4. du is 3 dx. There's not a 3 in the problem. So I know I need a 1/3 out front. Now I do, however, have an extra x. Remember, if you've got an extra x, we've got to go back here and solve for x. So I'm going to add the 4 and divide by 3, and that tells me what my x is. So that goes on top. And I have u cubed on the bottom. I'm going to move this out front, so that makes that 1/9. And then I'm going to separate these two things. So u over u cubed is u to the negative 2, and then 4 over u cubed is 4u to the negative 3 du. So I just separated those and reduced them and moved them to the top. So if I integrate this, this is u to the negative 1, so that's 1 over negative 1 out front, plus this would be u to the negative 2, which gives me that, and plus my c. And this 1/9 needs to go to everything. So 1/9, this u goes back to the bottom. It's negative, u is 3x minus 4, so negative 1, 3x minus 4. I've got another negative, so we're going to go minus. That reduces to 2. And then I have a u squared on the bottom, so 3x minus 4 squared plus c is going to be my answer. Number 9. Pretty basic on number 9. There is no need for a u. There's nothing inside of anything else. Sorry about that. So if I integrate 1 over x, I get the natural log of the absolute value of x, and we're going from 1 to e to the, I can't tell what that is. I'm going to call it a 5. So if I plug in natural log of e to the 5th minus natural log of 1. So the natural log of 1 is 0. That's gone. This cancels and leaves me with an answer of 5. That is if this exponent is 5. I can't tell if that exponent is 5. Alright, next one. Okay, there's only one e. Since there's only one e, that means its exponent has to be the u. But we don't want, if we just have one e, we don't want it to be on the bottom, we want to move it to the top. So if we move it to the top, that makes that 3x a negative 3x, which means my derivative is negative 3 dx. There is no negative 3. I've got an extra 2, so it comes out. I've got the negative 1/3 as well. So we're looking at u du. So negative 2/3 times, so that's going to be u squared times a 1/2 plus c. So these cancel. I get negative 1/3. U is negative 3x. Something's wrong. I forgot about it. I screwed up. This should be e to the u. Hopefully you guys caught that. So now if I integrate that, I get e to the u plus c. So negative 2/3. This becomes e to the negative 3x plus c. So hopefully you caught my mistake there as I was making it. 11. Our u is going to be 4 minus e to the x. Derivative of that is negative e to the x. I've got the e to the x. I do not have the negative. So that's going to be 1 over the square root of u du. That's the same thing as u to the negative 1/2. So add 1 makes it a positive 1/2. Multiplied by the reciprocal makes it a 2. Don't forget about the negative. And the plus c. So we're looking at negative 2. Our u is 4 minus e to the x to the 1/2 plus c. And this is another thing I noticed on the quiz is you integrated correctly here, and then when you put your u back in, you forgot to put this exponent down. So make sure once you have an exponent, you bring it down. Don't forget about that. All right, 12. My u is going to be sine. My du is cosine. Works out nicely for me. It's a straight swap. So that means we're integrating e to the u du. So that's e to the u plus c, which means it's e to the sine plus c. That one's pretty simple. Next one. So I have 1e, so its exponent, 1 over x plus 1 has to be my du. I'm going to rewrite this as x plus 1 to the negative 1 and then take the derivative using chain rule. So I bring the negative 1 out front. I got x plus 1, negative 2. It's not necessary in this case, but the derivative of the inside would be 1, so I go ahead and put it in there. Alright, so I've got the x plus 1 squared on the bottom, which takes care of this, but I've got an extra negative. So I'm going to put a negative out front, and we're going to make it e to the u du. Integrate gives me e to the u plus c. Plug back in. There's my answer to 13. All right, 3 more. All right, 14. Hopefully you notice you've got a polynomial on top of a monomial, which means we want to separate. So we do e to the 4x over to e to the 2x. That's 4x minus 2x, which gives me, let me write it over here. So that gives me e to the 2x, if I can write. And then this, I have 2 over e to the 2x, so we're going to make that 2e to the negative 2x dx. Yeah, I'm hoping we're pretty good at doing these and we don't even have to use a u. You can use a u on this if you want to. If you do, each of them have to have their own u since their exponents are different. So the first one is going to be 1/2 e to the 2x. And the second one, it's going to be plus 2 divided by negative 2 e to the negative 2x plus c. So if I clean it up, there's the answer I'm looking for. Again, if you couldn't do that in your head, then do a u for each one of these and integrate them separately. Next one, I've got a natural log in the problem, so that means that's got to be my u. 5 plus the natural log of x cubed. Derivative of 5 goes away. Derivative of the natural log is 1 over the inside times the derivative of the inside. And that reduces to 3 over x dx. Okay, I've got the x on the bottom. I've got an extra 3, so that means I need 1/3 du 1 over x dx. So 1/3, that's u to the 4th. I'm getting ahead of myself. Du. So if I integrate this, that's u to the 5th times 1/5 times the 1/3. Now I've got the plus c. So I have 1/15, and then I have u, which is 5 plus the natural log of x cubed to the 5th plus c. Again, this is another situation where you might forget that exponent. Don't forget that exponent. Make sure you bring it down. All right, last one. So we want to turn an integral into a limit over Riemann sum. So limit as n approaches infinity. We've got our sum, I equals 1. We're going to n, and then we need to put it on the inside. So I've got the 5 plus the natural log. So 5 plus the natural log, and then where I have the x, that's where I need to start working. So I'm starting at -4. So we're going to go -4 plus. I take the difference, which is 7. So that means I'm going to have 7i over n. That's inside of an exponent of 4. So I've got to put the 4 there, and then we need to multiply by b minus a over n, which gives me that. So make sure those two things match. And there's my answer on 16. All right, there's a quick rundown of the answers to this review. If you have any questions, send me a message. Also, as I've said multiple times, I'll be available before school on Wednesday and before school on Thursday if you have extra questions. We will take this test on Thursday. Let me know if you have any questions. We will see you on Thursday.